Research on fractions learning suggests that using visual representations can support students' understanding of fraction concepts and can help develop their skills in solving fraction problems. Research has also shown that teaching students to systematically use visual representations improves their ability to solve problems accurately and can increase their mathematical achievement. Visually representing the quantities in a fraction problem and using real-world examples helps students understand what a given fraction problem looks like and how to solve it. In this video, we'll look at several different kinds of visual representations and how they can help deepen students' conceptual understanding of fractions and support their problem solving. Some of these representations include multi-link blocks, area models, double number lines, tape diagrams, and apps for depicting fractions. Research has also shown that when teachers present multiple strategies for solving the same problem, students demonstrate increases in both conceptual and procedural knowledge. Using and discussing multiple strategies is also beneficial for solving ratio, rate, and proportion problems. For example, in a ratio problem, it can be challenging to visualize comparing, for instance, the value of a 12-ounce can of soup for $1.40 and an 18-ounce can of soup for $2.50. Instead of students trying to decide which numbers go in the numerator and which go in the denominator to apply an algorithm, we can set up the problem on a double number line. By locating ratios on a double number line, students can see how these ratios compare in a much clearer way. Or consider this problem. A recipe uses 2/3 of a cup of flour to make enough cookies for 4 people. How much flour do you need to make the recipe for 10 people? It might be easy to imagine doubling the recipe to consider how much flour you need for 8 people instead of 4, but the question is how much flour do you need to make the recipe for 10 people? We can represent this problem on a double number line. The top line shows the people served, and the bottom line shows the cups of flour. With problems like these, it can also be helpful to use free open source apps, such as GeoGebra apps. These apps allow much more accurate representations of tricky fractions, ones that might be hard to visualize, such as comparing 3/5 and 4/7. And the apps make it easy to revise and test different conditions. They give students immediate feedback and allow us to represent ideas that would be hard to demonstrate with hand-drawn representations. For example, here, we're mixing a can of paint with 3 cups of green paint and 9 cups of white paint. Not only do we get a nice depiction of the fractions involved using this tape diagram, but we can even see how the different ratios affect the color of paint. We can also use area models to show fraction multiplication when solving a problem similar to this one. Suppose we have 3/5 of a cake left in the cake pan. We want to frost 2/3 of the remaining cake with orange frosting. In the end, how much of the cake is frosted? Here we can clearly see the different fractions involved. 3/5 of the cake left, and then frosting 2/3 of that leftover cake with orange frosting so that 6/15, or 2/5, of the whole cake is frosted. After experiencing several problems in this way, students will have a better grasp of how to think about fraction multiplication. Especially when multiplying and dividing fractions, visual representations can help address common misconceptions, such as always expecting a smaller value when dividing fractions. Once students become familiar with visually representing fraction problems, instead of going directly to procedures, they begin to see and understand how the relationships between the numbers can be used to solve the problem. Visual representations also tap into students' natural curiosity as they search for patterns and engage more intuitively with the deeper reasoning of the mathematics. Educators who have been using visual representations with their students see their value and impact.
I've noticed the students really increasing their understanding of how to interpret the remainder in a problem and how to represent that as a fraction of a group or a serving. And in the past, I don't think I really taught students other than, using the algorithm for those trickier problems. But now students can actually see when they have a remainder, how to interpret it as a fraction of the group. And I think that's an understanding that probably most adults may not have, but our students are getting that understanding now. And I've just seen them grow a lot in that area.
The biggest change in conversations with students over the last few years has been them explaining why the answer is the answer. There's lots of ways for students to do that, whether they use a number line, whether they're using the blocks. But students can tell me now why the answer is the answer, and then they can defend that answer based upon the work that they have done. Versus in the past, I felt like a lot of students would just guess as to what they're doing and not really understand if the answer made any sense. Now they can make sense of their answers, which is what we all want.